Hey everybody, so today is going to be hopefully a pretty short lesson just to get you introduced to some definitions that relate to trapezoids, and then we'll spend some more time working on trapezoids in class. Okay, so first we need to identify what a trapezoid is, okay? So a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. And you have to be very careful with the word exactly. Okay? Because, so I'm looking up at this trapezoid. These are the parallel sides. Okay? These sides right here are called the legs. And this is called a base. And I know it's the top, so that's kind of weird. And this is also called the base. Okay? So the parallel sides are the bases. And there's going to always be two bases. Okay? Now, I also want you to think about trapezoids because the ones I put up there are isosceles. That means the legs are equal. But trapezoids can actually look very funny. We can have a trapezoid that looks like that, where these are the parallel sides. I mean, it could look like this. So it doesn't always have to look like the ones I have up at the top. So I just want you to be careful of that. And while we're at it, I want us to recall the area formula of a trapezoid, okay? So now we can talk a little bit more about it. The area is equal to the height times base 1 plus base 2 all over 2. I mean, we cut it in half. All right, so if this is base 1 and this is base 2, remember heights are altitudes, so they're always perpendicular segments. So that would be the height. All right, so that's just because we're going to need that later. So I put that in there so you remember. All right, an isosceles trapezoid is a trapezoid with congruent legs. Okay? All right, so I'm going to draw a trapezoid, and I know it's not so good. These are my parallel sides, the exactly one pair of opposite sides parallel, and these would be congruent, which is an isosceles trapezoid. So it's a special trapezoid. And the great news there is that it gives me some more information. We know, because of the isosceles trapezoid theorem, so the isosceles trap theorem, that the base angles of an isosceles trapezoid are congruent. But now we got to be careful because the base, it's got two bases, right? So if this is a base and this is a base, it makes these base angles equal to each other, and it makes these base angles equal to each other. Now you also might see, because of the parallel lines, that this base and this base are supplementary, and this base and this base are also supplementary, which is also true, okay? All right, so that's only in an isosceles trapezoid. All right, last definition, and I'm going to kind of review it a little bit, is the midsegment of a trapezoid. It's also called a median. Now, I don't want you to confuse it with the median of a triangle. Remember, the median of a triangle, okay, is a segment that goes from a vertex to the midpoint of the opposite side. A midsegment or a median of a trapezoid is a segment that joins the midpoints of the legs. Okay, it's a segment that joins the midpoint of the legs. So, for example, I put that those are congruent. That makes E the midpoint. I make these congruent. That makes F the midpoint. So EF is a midsegment or median. I'm using both terms because you may see it written as both, okay? All right, so now some things are cool though. If this is a trapezoid, as soon as I draw that median, you need to know there's a couple things that are true about it, okay? So number one, it's parallel to the bases, okay? And its length is the average of the bases. Its length is the average of the bases. What's also really cool is that if it's parallel to the bases, then couldn't we say that this angle and this angle are congruent because they're corresponding angles and because of the corresponding angle postulate? We could also say it on this side. Okay? All right. So I'm just going to do one little example of a midsegment, how we might find its length. If I give you a midsegment, I tell you it's a midsegment like that, and it's a trapezoid, and I tell you that this is 9, and this is 15, and this is x. All we have to do is calculate the average of the bases to get the midsegment. So we can do 9 plus 15 all over 2 equals x. So 9 plus 15 is 24. And 24 divided by 2 is 12. So the midsegment is 12. Now we're going to be working with that when you get to class on Friday. So I want to make sure that you really kind of think back to averages again, because we're going to make some conjectures based on that. Okay? Have a great night, guys.